In this program, we'll blink on and off a row of LED lights in a sequence. In the void setup function, set up 6 ports as outputs using the pin mode function. You can use single color LEDs and an RGB LED or 2 RGB LEDs for this program. In the void loop function, we have a for loop. And the for loop has 4 main parts. First, a variable with a starting value, a condition that is checked before the for loop is run, a change to the variable that happens after the code between the curly braces runs, and the code between the curly braces that runs when the condition of the for loop is true. In this case, we're creating an integer variable, shortened to int, and that means the variable can only have whole number values, no decimal places. We'll name the variable, and I'm naming it I, which is a very common counter variable to use inside a for loop. The starting value for this variable is 2 because that's the lowest port number we have on MakerBoard, and that's where our first LED is plugged in. Next, we have the condition of this for loop. This condition checks is I less than 8. We want the for loop to run until I equals 7 because that's the highest port we have an LED set up in. So if I is less than 8, we want the for loop to run. Next is the change to the variable that happens after the code between the curly braces runs. So we want to increase I by 1 each time the code between the curly braces runs here. Inside the for loop, we have a digital write function, and that requires 2 arguments. First, which port do we want a digital write to? Instead of using a number, we're using the variable I, which is going to change as the for loop runs. And we want to set that port high, turning on that LED. Next, there's a delay function with an argument of 500 for a 500 millisecond or 1/2 second pause with the LED on. Next, there's a digital write low function, and we're using I as the value of the port we want to turn off. Next, there's another delay of 500 milliseconds or 1/2 second before the program reaches the end of the for loop with this closing curly brace and runs the I++ code, increasing the value of the I variable by 1. Let's look at how this loop is actually going to affect the LEDs. The integer I equals 2, and 2 is less than 8, so the code between the curly braces is going to run. The digital write is going to set port 2 high, turning on that LED. After a delay of 500 milliseconds or 1/2 second, digital write is going to turn off port 2 with the low argument. After another delay of 500 milliseconds, the for loop reaches its closing curly brace, and I++ adds 1 to I. So now I has gone from 2 to 3. 3 is still less than 8, so the condition is true, and the code inside the curly braces will run again, setting port 3 high, delaying 500 milliseconds, setting port 3 low, delaying 500 milliseconds, and then reaching the end of the closing curly brace again. This for loop is going to run 6 times until I equals 7, at which point the digital write will set 7 to high, delay 500 milliseconds, set 7 to low, delay 500 milliseconds, reach the end of the for loop, and then run I++, making the I variable move from a value of 7 to a value of 8. The condition is not true if you ask, is 8 less than 8? So the code between the curly braces is going to be skipped over. There's no other code in this void loop, so the program is going to reach the end of the void loop and jump back up to line 15 and start running the for loop again, setting I equal to 2, checking the condition is 2 less than 8, and then running the code between the curly braces, turning on and off port 2. You could also add 3 more single color LEDs or your other RGB LED to get up to 9 different lights that are flicking on and flicking off in order with this for loop.